Hi Pre-Calc. Thanks for your patience. I was hoping to get this out earlier, but it just sort of is what it is in these times. So 4.6 is more graphing. We're going to start with the tangent function, and let me show you the standard table of the tangent function. So all in all, there'll be 4 tables, one for the sine, one for the cosine, one for the tangent, and one for the cotangent. So when you're graphing by the method I'm showing you for the tangent function, this will be the table. So it's going to go from negative pi over 2 to pi over 2. And you'll be able to understand a little bit better why we pick those values for the standard table when you see the graph. In terms of evaluating these angles, think about what tool I would use to do each of these angles. Would it be the unit circle and why? Would it be a reference angle and why? Let me just say that a little better. Would it be the unit circle or would it be the 2 triangles? So try to think when you look at these angles why I pick what and why I do that. So negative pi over 2 is a quadrantal angle. Negative pi over 2 is a quadrantal angle. It starts at the horizontal x-axis and rotates down to negative pi over 2, which is right here. So that's a quadrantal angle, which means I would use the unit circle to evaluate that. So negative pi over 2, the sine value is negative 1. Let me write it out over here so you can see it. Alright, so the tangent of negative pi over 2 is equivalent to its quotient identity of negative pi over 2 over cosine pi over 2. Sine of negative pi over 2 is negative 1. Cosine of negative pi over 2 is 0. So this is undefined. This point here is undefined because you're dividing by 0. What's happening actually in the graph is that you have a vertical asymptote. Negative pi over 4, that's rotating down to the 4th quadrant. Negative pi over 4 would have a reference angle of positive pi over 4. That would be the reference angle, which is the 1, 1 radical 2 triangle. So that's going to end up giving me, for the tangent, it's the opposite over the adjacent, so 1 over 1, but it's in quadrant 4, so it has to be negative 1 because the tangent is negative in quadrant 4. So again, negative pi over 4, that's the 45, 45, 90 triangle, which is 1, 1 radical 2. The tangent is the opposite over the adjacent, which is 1 over 1. And because it's in quadrant 4, it's negative 1. Okay, at an angle of 0, now you're back at the unit circle if you're an angle of 0. So the tangent of 0 is equal to the sine of 0 over the cosine of 0, 0. Sine of 0, as you can see from the unit circle, is 0. Cosine of 0 is 1, so overall that's 0. Pi over 4, that's going to rotate you into the 1st quadrant. Pi over 4 again, that's your 1, 1 radical 2. Sine of pi over 4 in the 1st quadrant is opposite over adjacent, so 1 over 1, which is 1. And since it's in quadrant 1, the tangent is positive. Okay, pi over 2, that's a unit circle. That's right here. This is pi over 2. So you're going to be using these values. So tangent of pi over 2 is equal to the sine of pi over 2 over cosine of pi over 2, which is equal to 1 over 0, right? The sine is 1, the cosine is 0. So this is undefined. So for this one, we get undefined. But really, what I would prefer you write in these boxes for this one is the VA, vertical asymptote. Okay, so this is the standard table for the tangent function. You want to keep hold of this. This table is important for this graphing method. Let's go ahead and graph this. I showed you how I got the values. So now I'm going to graph that. Okay, again, do your best to scale it. I'm not going to take a ruler to your test, but just, think about it. Okay, so if this is 3/2, it's 1.5. 1 would be about here. -1 would be about here. Alright, so now I'm going to, these values here, I'm going to move them over. So at -π/2, we have a vertical asymptote. At π/2, you also have a vertical asymptote. The reason you have a vertical asymptote is you're dividing by 0. At -π/4, we're at -1. -π/4 is half the distance here. Sorry, this has to be a positive one. This is a -1. Okay, π/4 is here. This is -1. So this is right here. At 0, we're at 0. And at π/4, which would be halfway here, we're going to be at 1. So what this shape looks like, it looks like this. The tangent function, it's a shorter function for one cycle than the sine or the cosine, right? Because the sine or the cosine, the width of one function is 2π on the sine and the cosine. But the tangent, the width of one function, if you notice, is going to be what? If you go from -π/2 to π/2, that's the width of pi. Okay? So now basically what I'm going to do is I'm going to take another, I'm going to like photocopy this. I'm going to take this and like photocopy it next to each other. There's 3 cuts in the middle. And the points go middle. We got one that's up one that's down one. And it looks like half a parabola up and half a parabola down. Looks sort of like a cube function. Okay? And then this is just going to repeat. I'll throw one over here. So I'm going to try to get the width about correct, about the same. Okay, gang, and then that's the general idea. This function just is going to repeat itself to infinity. It's going to repeat itself to positive infinity and repeat itself to negative infinity. Okay, so this is what the tangent function looks like. This is the table for the tangent function. And the formulas for the tangent function are slightly different, so they're good to note them. We will end up using them. So like the period for the tangent function, it's not 2π/b because it's a shorter function, so it's actually just π/b. The increment is still the period over 4. That's the same for all functions. And the interval is different. The interval is a start and stop. So the guts of this, the inside of the tangent function, has to start at the old start, which was -π/2. That's where it would, this is how you find the new start. And the inside of the trig function, the guts, this here is the old stop. So this would, you'd have to re-index it to the old stop. So notice this is not the same as the sine and cosine. It's not set equal to 0 and 2π. It's different values. Okay, so like I said, this is the table. These are the formulas. I'll do an example where we use them so you can see how they're used. Okay, I hope you enjoyed this video. I'll be back with another one. Bye-bye.